Alright, ladies and gentlemen, this is the practice quiz/test for Chapter 9. Without further ado, let's just get right into it. The top 4 problems is the only place I want you to state the domain, and the domain means state the restrictions. In other words, what x cannot equal in the problem, okay? Which, again, is done by setting denominators factors equal to 0. Okay? Alright, so let's go through and simplify these. Simplify means just factor it out. So this is x plus 4, x minus 4, over x times x minus 4. These cancel, so my solution is what's left, x plus 4 over x. And my domain is x cannot equal, well, set the denominators equal to 0. If I set that equal to 0, I get 0. If I set that one equal to 0, I add 4 to both sides and get 4. Okay? The next problem is already factored for me real nice, so the solution is just x. And the domain, again, if I set the denominators factors equal to 0, add it to the other side, I get x cannot equal 3. The solution here, well, let's factor the top, x and x, 3 and 1, minus minus. This is x plus 1, x minus 1. It's a difference of squares. Anytime you see two terms, it's either x plus x minus or it's a GCF. Okay? So in this case, these cancel. I get my solution of x minus 3 over x plus 1. And set each of these equal to 0. I get x cannot equal negative 1 or positive 1. If you wrote plus or minus 1, same thing. X minus 2 is what it works out to be. On bottom, we're going to have x. This is x times x squared plus 6x minus 16, which is x times x and x. Let's see, plus 8 minus 2 it looks like. These cancel. My solution is x minus 2 over x times x plus 8. And x cannot equal. Again, set this equal, I get 0. Set this equal, I get negative 8. Set this equal, I get positive 2. Okay. So, to multiply, remember we just multiplied directly across. We put that word, across. Okay, so I'm going to cross cancel. I got a 5 can go in each of those 1 and 3 times. I got a z that comes out of there. When I take a z out of there, I'm left with z squared. I got a 6 that goes into each of those. I got an x that goes into there and 3 times there. I've got a y that goes into there and 1 time there. And it looks like all I'm left with, 1 times 3 is 3, x cubed, y, z squared, all over 4. Right here we need to factor it first. When they're monomials, we can just go directly across. But for these, we need to factor them first. This is 3 times x minus 11, and then cross cancel. I can cancel out the x minus 11s. I cancel 15 and a 5 out to give me a 3. Looks like I can cancel x out of there and an x out of there to give me an x squared. And I'm going to kind of go like this because I already did those. So what am I left with? It looks like, oh, I still have a 3 here and a 3 here that can cancel. So I'm end up with a 2 on top and an x squared on bottom. And that's it. I don't need you to write the domains for the rest of these. I just want to do that on number 1. For divide and simplify, remember we need to keep it, change it, flip it. Remember that is KCF. So I'm going to keep the first term. Change the sign and flip the second one. Okay, so I've done that. Now I got to factor everything. So I'm going to factor, let's see, it looks like a 2x out of there and a 5 out of there. It's like I could factor a 2x out of each of these. I'm going to do this over here. 2x gives me x squared minus 5x plus 6. So that is 2x times x. On bottom I get x minus 11 x plus 1. This is going to give me, let's see, negative 3 and negative 2. Right, because I'm going to have a lot of crazy stuff going on here. Okay, so what can I cancel here? It looks like an x minus 11 can cancel. I've got, not a whole lot else. I do have something here where they're opposites. When they're opposites, you can just times one of them by a negative to get that to cancel. So I'm going to cancel this and write that as negative 1 times 3 minus x. We can do that. Or I could have changed this one, it doesn't matter. Now that will cancel with that. I've got 2x, 2x, negative 1, and an x minus 2 on top. So 2 times 2 is 4x squared times that is negative 4x squared with an x minus 2 there because that didn't cancel. On bottom I'm left with 5 times x plus 1. And there's my answer. That was kind of a crazy one. Let's do this next one. Again, keep it, change it, flip it. Now I'm going to keep it, change it, flip it at the same time. Okay? I'm going to factor this first. I'm just showing you can do this multiple ways. This is x plus 7. X plus 7. This is 8x times x plus 3. This is x plus 7, x minus 7. Now I'm going to keep it. Change it, flip it. So you can keep it, change it, flip it, then factor it, or you can factor it, then keep it, change it, flip it. I think it's easier to do it this way because a lot of people get here and then just start to cancel stuff, but you got to make sure that you flip it when it's this kind of fraction anyway. Alright, I got x plus 3 that it cancels, I got x plus 7 that cancels, I got another x plus 7 that cancels. Looks like all I'm left with is x minus 7 over 8x. Okay. Now, I guess you couldn't see the final answers, but there they are. You saw all the work before that. Okay. Down at the bottom here, I got to add and subtract on the next page, so I've got to find a common denominator. Remember what we've done with these is I've just written everything, so 3x and 5 gives me 15x. What's missing to get from here to here is times of 5, so I times the top by 5 and get 10. What's missing to get from here to here is times them by a 3x, so I times the top by a 3x. And of course, that 3x times x is just 3x squared. I cannot combine those, so I leave it exactly that way. This problem, x and x, x and x. This one's a little easier, I guess. 8 and 3 plus 8 minus 3. This one is either 6 and 1 or 2 and 3. 6 and 1 will give me 5, but not if I have one of them positive or negative, won't give me a positive 6. So I could have minus 2, minus 3. We can see all the terms we have. We have an x minus 2, we have an x minus 3, we have an x plus 8, and x minus 3 repeats, so I'm not going to do that. What's missing here that's here is, of course, that x plus 8. So I need to multiply the top and bottom by x plus 8. Distribute it out, I get 2x plus 16. Plus, what's missing here, of course, is x minus 2. So I'm going to do that to the top and bottom, get 4x minus 8, and then combine like terms to get my final answer, which is 6x plus 8 over x minus 2, x minus 3, x plus 8. Now remember again, you can FOIL that out if you want, but I'm not asking you to do that. You don't have to, okay? Go to the next page. So that was adding. Subtracting is going to work the same way. We need a common denominator. 5 and x minus 2. To get from here to here, I have to times the top and bottom by 5. So I get 15. On top, well, that's already the same here, so I just times by 1. And, oops, sorry, that's a 4. And then I have to just simplify it. 11 over 5 times x minus 2. For this problem, again, this is x plus 8. Should be starting to recognize these by now. 8, 5, minus, plus. Big factor is x plus 8, x minus 8, x plus 5. I'm going to probably just do this in just 2 steps here because here I'm missing x plus 5. So I'm going to do x plus 5 on top, and I'm going to get 2x plus 10. Here what's missing is x plus 8, so I'm going to times by x plus 8. But again, this is minus. This is a negative 4 that is getting distributed there. So I got negative 4x minus 32. And that's significant because if you forget about the minus, you'll have a completely wrong top numerator when you get to this. So negative 2x minus 22 all over x plus 8, x minus 8, x plus 5. Okay. Could you factor that? Yeah, you could pull a negative 2 out and get x plus 11, but there's nothing else that's going to cancel, and I'm not going to give you something else that's going to cancel on the test anyway, so just leave it like that. That's fine. Alright, so that's adding subtracting. When I get to just simplifying these types of problems, what I need to do is times everything by the common denominator. And the common denominator for 5 and 3 is 15. So I'm going to put 15 over 1 on top, I'm going to put 15 over 1 on bottom, and I'm going to distribute that into all of these terms. 15 times 2 is really 30 over 1, which is 30, plus tops times tops, bottoms times bottoms. So I'm going to get 45 over 5. Tops times tops, 30. Bottoms times bottoms, 3, minus 3 times 15, which is 45. Now let's simplify here. I've got 30 plus 9 over 10 minus 45, which is 39 over negative 35. And that's the answer. In this problem, I'm just going to times everything by x plus 3. Now, on top, they just cancel, and I'm left with 2 over 1, which is 2. On bottom, though, that's not how it works. It does cancel for these two, but it doesn't cancel here. When I distribute 1 times that, I get x plus 3 minus, and again, these are going to cancel, so minus 2. And then I can simplify that to get me there. Okay? For solving problems, you can think of either getting a common denominator, and once you have that, you can just set the tops equal to each other, or you can cross multiply and divide. For this problem, this is probably easier to just cross multiply. Here I get x squared equals 16, and I can just square root both sides. X equals plus or minus 4. Can I plug them both in? 4 over 4, 4 over 4, yep. Negative 4 over 4, 4 over negative 4, yep, it works. Moving on to the next one. This, again, I can cross multiply, or I can find a common denominator and just set the tops equal to each other. The common denominator here would, of course, be 30. If I times this by 6 and times the top by 6, I get 12x plus 18. If I times this by 5 and I times the top by 5, I get 15x minus 5, or minus 15, excuse me. Again, if I had just cross multiplied, that's what I would have got anyway, by the way. But they're equal to each other, so I can set the denominators equal to each other, so I can set the tops equal to each other. And when I do that, I just move x to one side and the numbers to the other. And of course divide. Now, check that. Does it work? Sure. If I plug it in here, I get 22 plus 3 is 25 over 5 is 5. 33 minus 3 is 30 divided by 6 is 5. Both sides equate. Getting down to the bottom here, we've got my common denominator again is going to be 5x on both sides. What's missing here is nothing, so I just times by 1. What's missing here is the x, so I'm going to go like so. What's missing here is a 5, so I'm going to times it and get to there. I've got a common denominator, so I can just set the tops equal to each other once I do that. Minus the 1, be careful. A lot of people want to add 1 because I see a minus sign here. The minus is attached to the 2x, not the 1. Those cancel. Negative 2x equals 14. And divide. Negative 7. Again, plug it in. Am I going to get a 0 there? Nope. Am I going to get a 0 there? Nope. Then negative 7 probably works, and in fact, it does. Alright, so next problem. Common denominator for all of those is going to be, let's see, 15, 12. That doesn't really work. How about, what number does 5 and 3 and 2 and 6 all go into? 30. Could you actually set it up on each side? Yep, I could do 15, and I could do 12, and then just cross multiply. But I'm just going to use 30 for everything. Times this by 6 to get 12x, times this by 10 to get 10, times this by 15 to get 15x, times this by 5 to get 5. Now the bottoms are the same, set the tops equal to each other. Get the x's on one side and the numbers on the other, and divide. And that's it. That's the whole thing. Take a look at this maybe one more time, go through it on your own, do what you gotta do to get yourself ready for the test, which is tomorrow. Have a good day.